All right, so let's set up another example. This one's going to be a little different. We're going to take one where we're given our bounds of integration and we have to solve it. And so let's see. If you started doing this problem, you might just start plugging into it, but I'm going to draw the region we're looking at first because it's good exercise and we're going to need it to solve the problem anyhow. So I integrate with respect to y first, and that goes from y equals x up to y equals 1. Actually, let me write that out. That's too many t's, but whatever. The bottom is y equals x, and the top is y equals 1. So I go up to maximum height here, y equals 1. And then my bottom is this line right here, y equals x. And then the outside part, 0 to 1 dx, where all that stuff is still in there, tells me that the leftmost value is x equals 0. Bottom always tells me left. And the rightmost value is x equals 1. So I go from here at x equals 0 to here at x equals 1. So my region looks like this. And it ends right here at this point because I end at x equals 1 on the line y equals x. So that happens to be where y equals 1 and y equals x touch. So it's this little triangular wedge. Okay, so let's go ahead and try to evaluate our integral. So somebody gave me this problem and I sit down and I say, okay, I remember my directions. I ignore the outside part. I look at the inside part. Ignore the outside part. And then this is a Calc 1 problem for me. But I run into a problem. I sit here forever. I'm panicking. I say, wait, I have no idea how to integrate e to the y squared. I can't do this inside part. This integral is just like too much for me. I don't know if you actually can do that. I think that's one of those ones that's defined like as a special function. So I can't do this. I don't know what the antiderivative of e to the x squared is, so I can't integrate e to the y squared dy. But I know this is equivalent to some kind of double integral of e to the y squared, where I integrate with respect to x first and then with respect to y. And actually, let's give ourselves a little bit more room here to fill that in. So that thing was too much trouble for me. But I know I'm integrating over this region, and as it's drawn, it goes with respect to y and then with respect to x. But there's nothing that's stopping me from switching it. So I could say, okay, let's do my left to right first. So I start back here at x equals 0. And then I end up here. Before I stopped at x equals 1. But now I'm going to stop at this line instead. I'm going to say, instead of looking at only the biggest left to right, like I do when x is on the outside, I'm going to look at this line left to right. And so I start at x equals 0, and I end at the line x equals y. And now my y becomes the one that I go top to bottom and only look for the biggest values. So my lowest value y is down here at y equals 0. And my highest value y is up here at y equals 1. And instead of taking integral 0, 1, x1 e to the y squared dy dx, I can take integral 0, 1, 0 y e to the y squared dx dy. If this switch right here between bounds of integration was tricky for you, please go back and check it out again. Being able to do this kind of thing is very important. The rules are just write down your shape and then ignore that somebody gave it to you in the order originally. Just write the bounds of integration like we would have for this example right here. So I've got that. And let's get some more practice evaluating integrals. So I've got y went from 0 to 1, x went from 0 to y, e to the y squared dx dy. So I ignore y to start. And this integral, e to the y squared, is really easy. Y may as well be a constant number, so it can come out front like that. So that's just integral from 0 to 1, e to the y squared times x evaluated from 0 to y. Integral of dx is x. So that's integral 0 to 1, e to the y squared times y minus 0 dy. I left that off, sorry. So this is integral 0 to 1, y e to the y squared dy. And now I actually can take this integral. I say, oh, that's a u sub problem. I take u equal to y squared, du equal to 2y dy. So that means y dy is du over 2. And I wish I knew which way you guys tend to do. Sorry, you all tend to do. I'm going to do the one where you change your number at the end. So this becomes du over 2 e to the u. So that's 1/2 integral e to the u du. So that's, integral of e to the u is just e to the u. But I have to plug back in my y squared because that's what u was. And I go from 0 to 1. So that's just 1/2 times e to the 1 minus e to the 0. That's just 1/2 times e to the 1 minus 1, if you care to turn e to the 0 into 1. That would be my answer. That part where I paused was just because you also could say u is y squared, so this becomes 0 squared and 1 squared, and then it just becomes 1/2 e to the 1 squared minus e to the 0 squared. You get to the same place. It just depends on how you were taught to do it. So I showed it this way. But if you prefer the other way, just remember your Calc 1 preference and do that, or Calc 2 preference and do that instead. But that's the solution to this problem. So this last part was just so you could see another integral. The really tricky new part was this switch we did on the first page.